Now that we know how to use the point slope formula to find the equation of a line, let's see how we can apply that to parallel and perpendicular lines. So please recall that two lines are parallel if they have the same slope, but different y-intercepts. Okay, now two lines are perpendicular if they have opposite reciprocal slopes. Okay, so we need to remember that in order to do what we're going to do for example 3. Okay, so example 3 here. It says write the equation of the line that satisfies the given conditions. Okay. So part A says the line has to pass through -1, -5, and is parallel to the line whose equation is 3x plus y equals 6. So the first thing we have to do is we have to determine the slope of the line that was given to us, because if these two lines are parallel and we know the slope of the line given to us, we just use that same slope. So let's see what we have. So we have 3x plus y equals 6. If I can solve this equation for y, I can very easily and pretty quickly get the slope of the line. So I want to solve for y. To do that, I'm going to start by subtracting 3x from both sides. Well, 3x minus 3x is 0. So that leaves me with just single y, so just one step when we solved it for y, and y is equal to -3x plus 6. So the slope of this line is -3, and that's what we need to use for this example. So we're trying to find the equation of a different line that has the same slope, so it has a slope of -3, but also goes through the point -1, 5. So we have -1, -5, that's our x1, y1. We have m equals -3, and we're going to plug all of that into y minus y1 equals m times x minus x1. Okay, so like I've said many, many times, write out the formula just as is, and then rewrite the formula filling in the information, and you'll start to remember it quicker. So let's see, y minus y1. Well, y1 is -5, so that's going to be y minus -5. We know what the slope is. That's going to be -3. And then x minus x1. Well, x1 is -1, so we're going to get x minus -1. Okay. So in the next step, I'm just going to simplify signs, and then in the step after that, I'll distribute. So instead of subtracting a -5, that's just going to be y plus 5 equals -3. And then instead of subtracting a -1, that's the same as x plus 1. So now I'm going to distribute. So let's see, I get y plus 5 equals -3x minus 3. So when I multiply the x and the 1 by -3, I get -3x minus 3. And then finally, we want to go ahead and write this in slope-intercept form. That's kind of the consistency that we've had throughout all these examples so far. We've written them all in slope-intercept form. So let's go ahead and solve this one for y. So to do that, I'm going to subtract 5 from both sides. On the left, the 5's cancel to become 0, so I get y equals -3x minus 8. And this right here is the equation of the line parallel to 3x plus y equals 6 that also goes through -1, -5. So you don't have to write this out every time, but I want it in your notes so you know truthfully what we are doing and what this answer means. Okay, so y equals -3x minus 8 would be the answer there. So looking at part B, it says we need to find the equation of the line. Remember, the directions say write the equation of the line that satisfies the given conditions. Well, the conditions are the line has to pass through 4, -7, and it must be perpendicular to x minus 2y equals 3. So let's just figure out the slope of x minus 2y equals 3. If we have the slope of that line, we can find its opposite reciprocal, and we'll know what slope we would need to use. So I've got x minus 2y equals 3. I want to start by subtracting x from both sides. So the x's cancel to become 0 on the left, leaving me with -2y equals -x plus 3. I now need to divide all three terms by -2. That'll finally isolate my y. So I divide by -2. Let's see, that leaves me with y equals +1/2 x minus 3/2. Okay, now that is that same equation that we were given just in slope-intercept form. So we can see here that the slope of the line is 1/2. But we don't want to be parallel to this line. We don't want the same slope. We need the slope of all of the lines that would be perpendicular to this. So what we want for for the lines that are perpendicular, so I'm going to do M sub P so we know we're talking about the perpendicular slope. We want to reciprocate the line and then change its sign. So we need to use a slope of -2. Okay, so the slope of the line that was given to us was +1/2. The opposite reciprocal of that is -2. So for our example, we're going to use 4 -7, and M is -2. So this is our x1, y1. And we're going to plug all of that into y minus y1 equals M times x minus x1. Okay, so again, I've just written out the formula. Let's now fill it in. So y1 is -7. So the left-hand side of this equation is going to be y minus -7. The right-hand side, I'm going to replace m with -2. And then x1 is 4. So I'm going to, in parentheses, have x minus 4. Okay? In the next step, I'm going to do two things. I'm going to simplify the double negative thing that I have on the left, and then on the right, I'm going to distribute. So instead of subtracting -7, that's the same as y plus 7. On the right, when I distribute the -2, I should get -2 times x plus 8, okay? Now, in order to solve this for y, I can write it in slope-intercept form if I solve it for y. So in order to solve it for y, I just have to subtract 7 from both sides. That'll undo that addition of plus 7 with the y. So 7 minus 7 is 0, y plus 0 is y, and that leaves me with -2x plus 1. So just so you know what we're having here, this is the equation of the line perpendicular to x minus 2y equals 3, but also goes through 4, -7. Again, you do not have to write that out with every answer. The answer is just what is the equation? The equation is y equals -2x plus 1. But in your notes, I want you to know what that means. Okay? Now, the next two examples, we have something that's kind of special. So part C, it says we have the conditions. These are the conditions that have to be met. We have to have an equation of a line that passes through the point -2, 3 and is parallel to y equals -2. So let's talk about y equals -2. Notice we're missing a variable. We're missing an x. Okay? That means we cannot touch the x-axis, but we have to touch the y-axis. So that tells me that this right here is horizontal. Now, parallel lines and horizontal lines. If you are horizontal, you are parallel to all other horizontal lines. Okay? If you are parallel to vertical, if you're a vertical line, you're parallel to other vertical lines. When it comes to perpendicular, horizontal lines are perpendicular to other horizontal lines. Okay? So I'm going to try to write that down here. Horizontal lines are parallel to other horizontal lines and perpendicular to vertical lines. Okay, so we know we're dealing with a horizontal line in y equals -2 because it has to cross the y-axis. It can't cross the x-axis. The only way for that to happen is to be parallel to the x-axis, which means this line has to be horizontal. It also has to be parallel to something. So all horizontal lines are parallel to other horizontal lines. So what we need is the equation of the horizontal line that goes through -2, 3. Well, in order to be horizontal, you have to be a y equals equation. The y that we have to go through is going to be 3. So we're looking for the equation y equals 3. That's it. That's all she wrote. You don't have to do anymore. You have to have a firm understanding of when things are parallel versus when they're vertical and what that means. Now, for part D, it looks like I forgot the actual D for part D, but the information is good, so let's just go with it. The line has to pass through -6, 1 and be perpendicular to x equals 8. Well, let's talk about x equals 8. If we have x equals 8, we can see right off the bat we're missing a y. That means we cannot touch the y-axis, but because we have an x, we have to touch the x-axis. So in order to touch the x-axis and not touch the y-axis, we would have to be parallel to the y-axis, which means we are vertical. Now, vertical lines are parallel to other vertical lines. And perpendicular to horizontal. Oh, I was like, that looks weird. I've got two written twice. All right. And perpendicular to horizontal lines. Okay. So we know that we need to be perpendicular to the line that was given to us. The line that was given to us, x equals 8, was vertical. So we're looking for the equation of a horizontal line that goes through a particular point. So we need the equation of the horizontal line that goes through -6, 1. Well, horizontal lines have to be of the form y equals. The only y we have here is 1. So we're looking for the equation y equals 1. Okay, so make sure you know how to deal with parallel and perpendicular lines. Remember, parallel lines have the same slope, different y-intercepts. Perpendicular lines have opposite reciprocal slopes. But then when it comes to horizontal and vertical, things are always going to be special. So make sure you have a firm understanding of what a horizontal and what a vertical line would be. And just know that horizontal lines are parallel to horizontal lines and perpendicular to vertical lines. Vertical lines are parallel to vertical lines and perpendicular to horizontal lines.